So in today's lesson, our last lesson of the chapter before we begin review. Oh, yep, question. Okay, so in this last lesson where we are proving triangles congruent, the triangles that we are dealing with are overlapping. And the biggest piece of advice that I can give you, the biggest tip, the biggest trick that I can supply you with is look at the names of the triangles and think about how many letters it takes to identify a segment and how many letters it can take to identify an angle. So how many letters does it take to name a segment? How many letters does it take to name a segment? Two. Whereas if I'm naming an angle, a lot of times I can get away with naming an angle using just one letter. Now, think about why I'm bringing that up. Look at the names of the two triangles in problem 1. Triangle WXZ and triangle XWY. Look at their names. How many letters do they have in common? 2. What 2 letters are they? Here. X and W. So if those are the 2 letters that they have in common, and the question is asking me what is the common side, without even looking at the diagram, what educated guess can you make about what side they overlap at? WX, yes. Absolutely. And if we were to trace these 2 diagrams, you would see that my logic is sound. Triangle WXZ is right here in red. And triangle XWY is here in blue. Notice what segment was traced twice. It was exactly the segment that we already identified, segment WX. So again, as a tip, if you're looking at the names of the triangles and they have 2 letters in common, it's a side that they have in common. If they have 1 letter in common, then it's a pretty good guess that they have an angle in common. So before we get into the problem 2, which you may have already noticed I created as a click and drag proof, take a moment within your groups to look at the your turn problem 1. Okay. Thank you. Someone else. Eagerly anticipating when I get to the point where one of you sits down and the other one is raring to go. I got the next one. Go ahead, Caitlin.
I got the next one. Unless she takes mine. Just like the freshmen do.
Sophomore.
No, she's a freshman. She's telling Taylor.
Okay, so we've got our given out of the way. Yes, they are right triangles. And I hope that I've given you a huge hint by indicating that I want to state that these are right triangles much more so than I want to state that those angles are congruent. Why? Why is identifying that they're right triangles significant? What property does identifying them as right triangles allow me to eventually use? We talked about this on Friday.
HL.
The hypotenuse length theorem. So eventually, I hope you're already kind of realizing we're going to use hypotenuse leg. Look at what was given to us. In that first statement, give me 1 second, Taylor. In that first statement, we are told that RT is congruent to US. What are those 2 segments with respect to our 2 right triangles? What are RT and US with respect to our 2 right triangles?
Would they be the reference? No?
No. I'm asking for some right triangle vocabulary here.
Oh.
Oh.
Are those really ones?
Segments. segment RT and segment US, that's given to me, Catherine. They're the hypotenuses of my two right triangles. Right. It's all right. They were absent on Friday. It's understandable. The hypotenuse, remember, gentlemen, the hypotenuse of a right triangle is the side opposite the right angle. It's also the longest side. Okay, so I've given away some information here. I've told you that eventually we're going to use hypotenuse leg to say that these two triangles are congruent. I've told you that US, or rather Catherine told us, that RT and US are the hypotenuses of these right triangles. In order to use hypotenuse leg theorem, I need the legs to be congruent. I need rather a pair of legs to be congruent. What triangles, look at the names, ladies and gentlemen. Look at the names of these two triangles. Think back to problem 1. Think back to the tip I gave you about looking at the names. What do you notice? One person, please, about the Kristen.
They have the two of the same things, the S and R.
They have S and R in common. So notice segment SR.
Would you say SR is congruent to SR?
Absolutely, you would say that, or RS, same thing.
Yeah.
You would say that RS, that's teeny tiny.
I don't know what I did.
That RS is congruent to RS. Why?
Reflexive.
Reflexive. We know that one.
Favorite.
And now I have my 3 pieces of information. Caitlin, are you clicking and dragging?
Well, it might be URS is maybe TSR because there's 4 of them.
Well,
Yeah, but it's the triangle.
it's the triangles that you're trying to say something about, not the angles anymore.
What? Oh, I don't know. Oh, did you say the triangle? Are you congruent? Yeah, triangle. I'm not telling you the answer because I don't know if they're
What is CPCTC?
This? You can ask it to them.
I
Oh,
really have that.
corresponding parts of the congruent triangle are congruent.
So
Thank
it's
you.
like,
So finally, remember, after you say that two triangles are congruent, what property do we end up using right after that?
the hypotenuse.
No, we already used the hypotenuse leg theorem. The property that we use after we say two triangles are congruent, ladies and gentlemen, is CPCTC. And that's what we're using finally. And I don't have my last statement up here.
Oh, okay. That would be why I was so confused.
Angle T is congruent to angle U
That's why I was so confused. I was looking for that.
because of CPCTC. Sorry about that. Nothing like user error.
so wait, if it's an angle that you're trying to prove, it's CPCTC.
Let me clarify. Understand what CPCTC stands for. It stands for corresponding parts of congruent triangles are congruent. What it means, Taylor, what it means is that once I've said that two triangles are congruent, I can say that any of their corresponding parts are congruent. Looking at this diagram, do you see that the angles that I set out to prove congruent are corresponding parts of the two triangles that I just said were congruent? Okay, so a lot of times, and previously, up until last Monday, our proofs were always prove that the two triangles are congruent. And then on Tuesday, we went the next step further, which was this CPCTC. And in general, if you're going past saying two triangles are congruent, the reason that you're using, yes, is CPCTC.
And it can't be used before you say two triangles are congruent.
Very good question. No, you cannot use it before you say two triangles are congruent. We have from the screen what we need. Okay. Think about what property you use right after you say that two triangles are congruent. Even though it's at the beginning of the proof, that doesn't change that line of reasoning. There's only one property that we've ever used after we said two triangles were congruent? Remember, it's the only property you've ever used right after you say that two triangles are congruent. Same property you only ever used right after you say two triangles are congruent.
Can we go up there if we have one of them?
Not HL. CPCTC. I'll go to erase reason 2 here.
What is it, Taylor? CP what? It's CPCT. What?
CPCTC.
Oh, what are you doing? What are you doing?
Filling it in.
CPCTC, right?
Yes.
Oh.
Wait.
Haley, you've been She just
Which vertical angles are congruent up here? Taylor, right, man?
Got this.
Right.
Got that?
Oh, I don't know.
It's okay. I'm not dead yet.
Don't mess up too.
Shut
It's okay.
up.
Oh,
Be nice, remember you're still recording.
Oh, I did it.
oh yeah, we are recording.
Future self. I'm awesome.
Let me got it off.
How do you do this, Clouse?
I'm old.
What?
Learn lots of things by experience. Angle AEC, is congruent to angle. Put the angle sign, please.
Angle bend.
Yes. Okay, once we have that, then the triangles are congruent by what?
By 8. Well, yeah.
Yeah.
Here, I'll come draw it on the diagram.
Because I would have these angles congruent,
And A and
these
A,
angles congruent,
and the
and then
segment.
that's congruent to that. So yes, that is angle side.
That is 8.
And then tell me again, what property do you use right after you say two triangles are congruent? CPCTC.
Oh, so I was right. So wait, it could be 2 CCP?
Absolutely. There's no rule against that.
Wait, can anything be there more than one? Be there more than one?